Again, good morning, grade 8. This is the second time that I actually activated the Zoom meeting in order for us to clarify more. And the first actual discussion was not recorded. That is why. Again, in getting the number of protons, neutrons, and electrons, number one, let's have bromine again. Okay? Or other elements. Shall we say selenium? Okay? Selenium. Let's have selenium. Okay. So your selenium has, by the way, in writing, be specific. Okay? Selenium. The element is selenium. Okay? And your element has the atomic mass of, what is the atomic mass of selenium there? Let's just use 78. Okay? Let's just use 78. Okay, the superscript should be the atomic mass. And the subscript, can you still hear me?
Yes, sir.
Okay. And the subscript is your atomic number.
Yes, sir.
What is the atomic number of selenium? Atomic number of selenium, we have, just open again your periodic table. The atomic number of selenium is 30. What? 34.
Sir, I think I lost
Against
the answer.
selenium.
I lost my periodic table.
You lost the periodic table?
Yeah, I guess I accidentally changed.
34.
34. Okay. Wait, Janine, I'll just share it in the chat box for a while. Okay, it's 34. Let me share first the, wait. I'll send it in the chat box and please download it, Janine, before this meeting ends.
Yes, sir.
Okay, so selenium is 34 atomic number, and let's have the atomic mass of 78. Okay, let's calculate now the number of protons, neutrons, and electrons. Let's have first protons. How many protons do we have? We have 34 because in calculating the number of protons, it is equal to its atomic number. How about electrons? How about electrons? We have, are you still with me, Janine and EM?
Yes, sir.
Okay. Yes. We have atomic number minus its charge, so 34. But we don't have charges here because this is not an ion or nor a cation. Okay? It is in the stable state. How about the neutrons? The neutrons is equal to its atomic mass, okay, which is 78, minus 34. Okay? 78 minus 34. What is the difference?
The difference are the numbers.
What are the difference? 78 minus 34?
58 minus 34.
It's 44. Okay. The neutrons there is 44. Okay. So this is now your number of protons, neutrons, and electrons. How about if it is a positively charged? Okay. Let's have plus 3. What is again an element with a positively charge? It is called
Protons.
Protons. An element with a positive charge. Grabe?
Positive ion.
Positive ions or
Cation.
cations. Correct. Because it is positively charged. Cations. So in getting again the number of electrons, because these ions differs on the number of electrons. Okay? We need to deduct the charge in the electrons. Okay, 34 minus its charge, which is positive 3. So the result is 34 minus positive 3. The result is, Robbie?
44.
Huh? 34
44.
minus positive 3.
Wait, what? Positive 3.
34 minus positive 3.
31.
31, correct. It's 31. It is deducted. Okay? So, if this element is an cation or a cation, it has 34 protons, 31 electrons, and 44 neutrons. Again, it has more protons than neutrons or than electrons. Therefore, it is considered as a cation. How about if we will change this one to negative? Okay, negatively charged. What do you call an element with a negatively charged? Ion.
Negative ion.
If this is negative 3, it will now convert the element into an ion. Okay, there you go. An ion. So instead of having positive 3 here, we will convert, or we will write here negative 3. Okay. 34 minus negative 3. What will be the result?
31.
34 minus negative 3.
31.
31? Why?
Ay. Huh?
Why it's 31? Minus negative? Again, if it is, if the negatively charged or negative will be deducted, it will become positive lagi. This will become positive. Okay. So 34 plus 3, it will become
37.
37. So you are now making more electrons than protons to make it an ion. So again, an ion is negatively charged. Okay? Cation is positively charged. When you say negative ion or negative anion or negatively charged ion, it has more electrons than protons. Okay? If it is cation, it has more protons than electrons. Are we clear with this?
Yes, sir.
Okay. Let's tackle simple example in electron configuration. Let's go back to electron configuration. Okay. So let me share my screen. You see my shared screen now with the electron configuration?
Yes, sir.
Okay. Let's have the element Um, let's have, wait, selenium, which is 34. Selenium has 34 as the atomic number. Okay. Selenium. Okay, let's have it here. Se is equal to 34. Correct? Selenium has 34.
Yes, sir.
Okay. Since it has 34, we need to get only 34 electrons in those subshells. Okay? And it should be inserted on the orbitals. Okay? How do we get the protons, neutrons, and electrons? Or how do we get the electron configuration of these elements? Simple. Okay? All we have to do is to what? Follow the electron configuration pattern. So again, S suborbital can only accommodate up to, this is S, up to 2 electrons. P suborbital can accommodate up to 6. Okay? D suborbital can accommodate up to 10, and F suborbital can accommodate up to 14 electrons. Okay? 2, 6, 10, and 14. Now, we are ready now to what? To extract the electron configuration of selenium. Okay? Let's start with 1s. Okay? 1s, 1s. What is the maximum number of electrons does the s orbital can contain? How many electrons?
7. Ay, 2, sir. 2.
It's 2. Sir, asa pa niyo mo gikuha ang 2? Here. Tara, oh. It's 2. Kini sila tanan, this line here can only accommodate up to 2 electrons. Okay? This line here can only accommodate up to 6. This line here can only accommodate up to 10 electrons. Napo ra kabuok ang magunitan. Okay? F can only accommodate up to 14. 14 ra kabuok ang pwedeng magunitan sa kana nga orbital. Okay? So, let's start with 1s2 and followed by 2s2. Okay, followed by 2p. What is the maximum number of electrons? What is the number
6, sir.
of electrons? We have
6.
4p. P? Pero p naman ta, di rin naman ta, di ba?
Yes.
Oh, what is the number of electrons?
6.
6. Right. 6. Going down. 3s, the maximum number of electrons is 2 because we are still here, di ba? And how about this one? Going to 3p. Maximum number of electrons in p again.
7.
7. Pero oh,
Ah,
ano naman mo?
6.
We are still in the p. You follow the sequence. You follow the arrow. P, wala mo tayo 7 diha. Okay, P6. And followed by 4. S. the maximum number is 2. So 4s, 2. Followed by, okay, ano na ta sa pikas? Di rin na ta. 3D. Okay? We're here na, 3D. So what is the maximum number of electrons for D?
10.
10. Correct. So this is 3D 10. Okay? You count 10 to 4. 4 plus 6 is 10. Okay? 2 plus 6 is 8 plus 2, 10. So 10, 20, 30. It's already 30. Okay? So let's move now to 4P. 4P. What is the maximum number of electrons does the P orbital contain? What is the number of electrons?
10.
P?
Oh, wait, no, P. 6.
6. Do we need 6? If I will write it 6 here, how many electrons do we have all in all?
6 electrons.
How many electrons all in all? Tanan.
6 electrons.
Huh?
6 electrons.
6 electrons all in all? How about this
Ay.
one? Hindi ay. Hindi sila. How many electrons all in all? We have, so you will count the superscript, okay? So 2, 4. 2 plus 2 is 4. 4 plus 6 is 10. 10 plus 2 is 12. 12 plus 6 is 18.
34, sir.
18 plus 2 is 20. 20 plus 10 is 30. 30 plus 6 is 36. Right? So it's 36, correct?
Yes, sir.
Okay. But
Yes,
we
sir.
only need 34. So we will not write 6 here. Instead, we'll be writing what? We'll be writing 4 to make it 34. Correct? So this is 4P4. And your 4P4 is the exact location of your element. Okay? That is the exact location of your element 4P4. Let me share my screen. 4P4. This is P. Okay? 1, 2, 3, 4. So it's in 6A. 4. Okay? 6A4. Let's check if it is in the 6A4. Okay? 1, 2, 3, 4. Okay, it's in 4. Correct. So that is the way how we can actually extract our electron configuration basing on the atomic number. Okay, I think that will be for today, class. Thank you for your time. Let's have more examples by next meeting, and hopefully also you will do your part because I'm helping you out. This is a long topic, and yet we're making it as short as possible, making it easier for you. I think that will be all for today, class. Have a nice day, grade 8. Goodbye.
Goodbye, sir.